we can just see that it goes up by 20. It doesn't really matter how you find your difference, 120 minus 140 or 140 minus 120. The important thing to remember is that this number is positive. So if you actually set it up and you look at the difference in years, you'd probably write it like this to indicate that there's a rise of 20, and that's $1,000 per 3 years. Now, if you just saw it as being, okay, it's up, this increases by 20, this increases by 3, you didn't really have to go through worrying about setting up this sort of fraction. You could just do it by observation pretty quickly. So if it goes up by 20,000 every 3 years, and we're assuming that the ratio is roughly constant, well, 20 divided by is about 6.7. So we'll just go ahead and round it, and don't worry too much about working with fractions, because ultimately we're going to round to some extent anyway. So we're saying $6,700 per year. Okay, well that's if we averaged it out, right? So if every year the house increased by the same amount, it would be about $6,700 per year. And if you prefer, you can put it over 1, and that way you can see it's $6,700 per 1 year. Okay, so we know that our price initially started at $120,000, but it's increasing each year by $6,700. Well, we don't want to just have the price is equal to 120 plus 6.7, because 120 plus 6.7 is 126.7. We want to indicate that it goes up by this amount every year. So what do we multiply it by? Well, we multiply it by the number of years that have passed. That way, if we say, well, t is 0, in other words, we're in 2009, then we should be able to see 120 plus 6.7 times 0 gives us 120. If we put in 1 for t, then we have 120 plus 6.7 times 1, and we get 126.7. And so every year we notice that it just increases by 6.7 more. And so there is our equation. Now if we wanted to take a look at this on the graph, of course we had it sketched back here as approximately how it would look, but now let's begin to think about how we would graph this on our calculator. So we're going to go into our y equals, clear out anything that's in there. I recommend going to second y equals and ensuring that all these plots are set to off. If they're not, select option 4, take you back to your home screen, you press enter, and it just says done. That means it's turned all of the plots off automatically. So we'll enter 120 plus 6.7, and we'll just put an x because we don't have a t in the calculator, we just have y and x. And now we have to think about it, well, if we just hit graph, we're not going to see much. So let's think about practical domain and practical range. So our x represents the years. We probably aren't going to go before 2009, and maybe, well, how far out do we think this should go? Maybe 10 years, so 2019, maybe 7 years? I don't know exactly. That's kind of up to us to decide. The home value should never be negative, so we would start it at 0. And to determine how high the home value is going to go, well, it starts at 120 and increases by 6.7 every year. So if we go out 10 years, we should be fairly safe to say it probably within those 10 years won't go any higher than 200,000. To figure it out exactly, plug in 10 for t, and you'll be able to figure out what it would be worth in 10 years. Now we should be able to hit graph, and we should be able to get a fairly reasonable image of what's happening to the home values. So there we see it, and it's going up constantly. So we decided that for our domain, that t is going to be at least 0, but no more than 10. And for our range, the price is going to be between 120,000 and, well, if you put in 10 for t here to see what it's worth in 2019, you'd get 187, I believe. And you can verify that in your calculator. So this allows us to set our calculator window, and that's why it's so important to think about domain and range. So our initial value, which is 120,000, I'll just abbreviate IV, is 120. So what does this mean? We're asked to explain the meaning of. This means that in 2009, the home value was